Welcome back. Let's go back to Python. So we'll be testing an async application. That's the title of this video. So in our agenda, we have the introduction of a coroutine. We will introduce a coroutine. What is a coroutine? A coroutine in Python is just an wearable object. By wearable objects, I mean a class that implements the magic method awaits. Down there awaits. Next, we will test a task in asyncio module. A task is just an instance of a variable that runs concurrently. We will also test a transient async IO loop, as well as testing a permanent loop. We look at that, what is the difference between a transient loop and a permanent loop. We will mock a coroutine, how to mock a coroutine. We will also mock an async IO loop. Why should somebody mock an async IO loop? Or there are instances where you need to make sure in your test you cover the loop. So there is a possibility that you can mock an async IO loop. And lastly, we will introduce the class ThreadPoolExecutor, which is a class in the concurrent module in Python. We look at that. Okay, now we need to cast some daemons about async IO. By casting daemons, I mean just debunk some concept that's make async IO to be sort of this crazy module that's kind of like I don't want to work on that. Okay, no, just making async IO mysterious, I should have said. So there are two concepts we need to understand about parallelism and multiprocessing. We have multithreading. When we talk about multithreading, whether in Python or any programming language, we refer to those tasks that are prone to memory utilization. And that's where our module, the async IO, will be utilized. We will use the async IO to run multi-threading or single threading. When we're using a loop, we have a single threading event loop. We also have the concept of multiprocessing. In Python, the multiprocessing as of today is managed by the module concurrent. So the multiprocessing are tasks that are prone to CPU utilization. As you can see on the right side of the screen, we have a process. A process aggregates a thread. So for each process, we have at least one or multiple thread. That's pretty simple. So make sure that you understand what is a process and what is a thread before going further with the async IO. Last but not least, we have Python packages that we'll be using so we can demonstrate how to test the async IO. We have the famous pytest. Pytest is a Python testing framework. It is built on unit test, but pytest is more readable, more flexible to test Python application. We will also use the pytest-asyncio, which is a package, an add-on that's extend pytest for testing Python coroutine. And we also have the pytest coverage. The pytest coverage is dependent on package coverage. It's a plugin for reporting code-based coverage. We will not go deep on those two packages, asyncio, pytest-asyncio, and the pytest-cov, but kind of like demonstrate how we can use them and how we can test our Python program with them. Okay, let's go on the demonstration and start writing some codes. start with a clean project. As you can see, I have a project here in PyCharm. I have a package called test, a clean project. To start, we need to create our new file, the test named test coroutine. Create our file. We can add that so we can start tracking what else we need. So we can start testing. Let's import pytest test simple coroutine. What are we gonna test? Some results which waits from a coroutine called compute loop that takes in parameter 2. Set results equal completed. Okay, that's all we need. Of course, we need to make sure that pytest is installed. Test. Okay, we have pytest installed. It's 7.1.2. okay, now let's test pytest. By default, pytest will look for any folder name test and the file name, any file starting with test. Okay, okay, we got our first error, which means that we are using a variable. We await from a function, but this function is my coroutine, so we need to make sure that this function should be coroutine. Let's test again. Okay, there is another error. We deprecation warning, the async mode, the default value will be set to strict in future. Please explicitly use async mode strict. So we need to pass a new parameter, a new argument. Pytest async mode equal strict, or async IO mode. Async IO mode equal to strict. Okay, it looks like it can recognize that, but still is saying that pytest and end or coroutine warning, which means it couldn't end or pytest couldn't end or this coroutine. To do that, we need to make sure we are using the pytest async IO. Let's verify that we have pip show pytest async IO. Okay, we have the pytest async IO. If you don't have that, you can pip. Before you install that, make sure that you are using the pip or on your activated environments. Show pip which pip. We can see that we are using the pip bin from async virtual environment, and then we can issue and install pytest-async. Okay, it's already satisfied. We have that. So if we have our pytest-async IO, we need to decorate this function. pytest-async. Okay, now let's run the test. Oh, now you can recognize that this test is a coroutine test, but the compute loop is not defined. We need to create our compute loop. By the way, as you can see, we have the folder .pytest cache, which is automatically created by PyCharm. To avoid PyCharm creating the pytest cache folder, we can issue, let's delete that first. Delete. pytest async IO mode for strict. We can pass the -p, which stands for plugin, and cache provider. As you can see, we run our test, but PyCharm cannot create our cache, pytest cache. Cool. Now let's make sure that the compute loop is defined. And create a new file here, name computes, and we can import asyncio since we need to in, and create a function called async. Yeah, we are going to use the asyncio, but for now let's just create a coroutine called computes loop, which receive integer in a string for elements in the range of 4 times the number. Print now working, and then we'll return completed. Very simple. We want to test a coroutine. Now the coroutine, the compute loop is not defined. We need to import that from compute coroutine import compute loop. Then bingo. Okay, that's the way we can test a simple coroutine. So next we are going to look the way we can test a task. So now we need to test the task. We will see the difference between a coroutine and a task. As I mentioned in the beginning of this video, that a task is an instance of a coroutine that's run concurrently. So test simple task. We have results equal asyncio, which needed to be imported. We import asyncio, and then we run automatically computes loop, passing just 1. And we accept our results equal this again. Pytest E for plugin, no cache provider to avoid PyCharm to create that pytest cache. Asyncio mode equals strict. Asyncio mode. Nice. So we need the sync. Okay, our 2 test is passing. But notice what's happening here. To test a coroutine, we needed a decorator pytest mark asyncio. But to test a coroutine as a task, we are now, pytest is now requiring the decorator. Why? Because in our first test, we are just testing a coroutine without creating an instance of a task. That's why we need this decorator. But for the second test, we are creating an instance of a coroutine by creating a transient loop. When you call asyncio run, you automatically create a loop. You open a loop, run the task, and close it automatically. That's the difference. That's the way we can test a task and test a routine. Okay, now we need to test a transient loop, or a transient loop is already demonstrated here by testing a task. A transient loop is just a loop that is automatically created and close when the task is completed. It's not a permanent loop. Okay, now let's demonstrate the way we can test a permanent loop. To do that, we need to make sure that instead of retaining a task in our test, we want to retain a future. And I know all this concept is so much intimidating when you hear a concept like a future task variable. It's at the beginning those concepts sound really intimidating, but it's not that really complicated if you wanna understand. So we need to test a permanent loop, which is different than a transient loop by executing run. To do that, we're gonna create a new test file. Let's create a new test file. We name the test permanent loop .py be under test. Okay, so we need to test a permanent loop. Let's call the test should return the future. And what are we gonna test? We wanna test that our results from a future. A future it's a task that is should retain any variable instead of retaining a result. That's a future. So what are we gonna do here? Let's say we want our we call that called our result sets. In the result set, if we pass any number like a 5, we want to assert that the result should be equal to something like completed times 2 or times 5. Okay, we can say n is int. It's gonna take the number of time times, which means this feature will be an array that takes in the number of the time that our compute loop will be should run. We look at that. This time we can just test. Let's import pytest. Okay. Let's test pytest plugin cache provider asyncio code street. Okay, we got an error. What is the error? Let's look at that. It's a picture. The picture n is now found. So which means if we want to run our test with the parameter, we need to make sure that the parameter is on the picture, so we don't have picture data. Let's create a picture n. Let's define the function name number, and this number will return, let's put that 4 pytest picture. Okay, we want to make sure that the picture will be applied to this test. Apply our picture and see what's going to happen. Run the test again. Okay, now we can recognize a number as a picture which retain 4, but we get on this line 10. Result sets is now defined. We need to define the result sets. Let's go back at compute coroutine. Let's create a coroutine async def called result sets, which takes in parameter number or number of tasks. Okay, now we need to create we want to run a compute loop asynchronously. Run compute loop with number of tasks as a parameter. So to do that, we use a method in asyncio-gather, and gather takes in a list of tasks, which means we need to create a task. We need to create a task. To do that, we can let's call that list. Let's call that tasks, and the tasks should be a list of compute loop. So compute loop I for I in the range of, let's say number of tasks. I in range of number of tasks, and we got our results, and gather, we pass the task as a list of tasks because we need to await the async gather, and we return our results. Yeah, let's just return the result and see what's gonna happen. So we're expecting the results to be completed n time, n number of tasks, which is gonna be kind of like a completed, as we are testing here. So from compute coroutine, import result set. Our result set is defined. Let's test and see what's gonna happen. So we got a result that said that the coroutine result is now equal to complete times 4. We need a loop here. We need a loop. If we want to create a permanent loop, we will need to pass loop as a async-io loop. So async-io abstracts. So async-io is now defined. Let's import async-io. Import async-io. What's up? So async-io abstract event loop. That's the type of the event loop. We want to make sure instead of returning a coroutine, we want to run a coroutine as a set of tasks, and we can only run a coroutine using a loop, and we're testing a permanent loop. Let's call our loop run until completed, until complete. Let's run the test again, see what's gonna happen. Okay, we got the same error. Loop picture is now defined, which means we need to create this loop. Go ahead and create a picture called loop, which creates, let's create a new loop, async-io, new event loop. Decorate that as a pytest picture, test picture. We yield the loop, and then we close the loop. So what's gonna happen is that when we're using our picture loop, it will not just be transient as the one we apply on this test, run, and then when it completes, it close. This one we run, it will open as long as the test is valid. It's gonna open, and then close when the test is completed. It's only gonna close the loop when the test goes out of utilization. Okay, let's test that again. Okay, as you can see, our test is passing. We got 4 completed, which means we got completed times 4. Let's see what's happening on the coverage. If we run pytest and then we pass the coverage test. Okay, the coverage argument is now recognized, which means we need to install the pytest-cov. test coverage install pytest coverage. This will also install the coverage package alongside with, as you can see here, it's installed coverage and pytest-cov, because pytest-cov depend on coverage. Okay, let's go back and test again with the argument cov equal to test, telling pytest to cover everything in the test. Okay, as you can see, we got 100%, which means there is no missing, which is a good sign. Okay, what are we now? So far, we've introduced a coroutine, saying that a coroutine is just a variable object that implements the done that awaits. We test a coroutine using the pytest decorator pytest mark.asyncio. We also test a task. We also make a demarcation between a transient loop, which is run using asyncio run, and a permanent loop, which is run by creating an event loop by opening and closing. Now, we need to talk about mocking. How can we mock coroutine? Okay, let's mock a coroutine. To do so, you can create a test called test mock coroutine.py. Okay, so let's see if we want to mock coroutine. We are going to need the async.io, so let's import async.io. We also need the magic mock from unitest. So from unitest.mock, import the magic mock. Quickly, we can create our test. Okay. Test mock routine. Let's also import the patch. Okay. So what are we patching? With patch, we patching the compute coroutine compute loop. We want the results to be this gonna return. It should return something like a mock. It should return a coroutine, right? Because we wanna mock a coroutine. Let's call magic mock. So let's create the coroutine from magic mock. So let's call that magic coro. And if we just call the magic mock, it will retain a magic mock. It will not really be a top coroutine. To do that, we can create a simple, let's say, def coroutine. We just create a coroutine, and then we call magic mock by passing the coroutine as a argument, which gonna return the magic mock will be of type coroutine. Magic, let's just call it just say mock coro. Okay, or mock underscore code. So as mock coroutine, this should be a return value. Yeah, that's the property. And then what are we gonna mock here? We wanna mock the compute loop. We can just await compute loop, or we can instead of calling the compute loop, we can use the permanent results, or we can use the result set. So let's import the result set. from compute coroutine import result sets, and we can call the result sets and pass in parameter 3 times, and then we can accept search mock coroutine when we create. Okay. We don't want to have a variable that will shadow the preceding variable. So mock coro asserts as a weight, right? We want to assert that your result set as a weight because we're mocking compute loop, right? We want to assert that the result set as a weight. It has been called 3 times. Need to use call from the mock, the import call 1, and then 2. So it's been called 3 times. You can pass another arguments, any order true. If we set any order to false, we assuming that it should be called, the way we set it, like from 0 to 1. We shouldn't be doing that because we are running tasks asynchronously. Maybe the call 1 should be before the call 0, and so we want to set any order to true. Okay, clear. And now let's test with our coverage what's gonna happen. Now we got the error awaits is outside of async, which means we shouldn't await a coroutine or a future if our function is now a coroutine. So use the syntactic sugar, the async. This one should be async because we are using a variable here. Test again. Okay, we got the error that we've experienced previously when we started saying that the pytest, which means that when we're using pytest with any function that any test that is coroutine, we need to decorate the pytest code. Pytest. As of now, we are now using pytest mark. This one is a coroutine, so async, instructing the pytest to recognize this test as a coroutine. Okay, let's test again. Bingo. So our test is passing. We successfully mock a coroutine using a magic mock. We transform our magic mock from a simple magic mock but a mock that return a coroutine by creating a simple coroutine and passing it on the instance of magic. There is also a package called asyncio that extend the unit test mock, which make it very simple. I mean, it's a package called async mock that I've said, but we're not gonna use that. I found out that the technique, it's more like a cumbersome. It's better just to use a magic mock and modify the magic mock. Okay, that's the way we can mock our coroutine. Next, we are going to mock an async loop. Yeah, you're probably wondering why should we test an async loop, because the loop is already happening here when we are waiting from the result set. The thing is that sometimes when you create your, let's say we go back on our compute coroutine, if we want to run this file as a script, we will require to do something like if name equal main, then loop equal asyncio gets event loop. The event loop here, we're getting the event loop because as soon as we execute this module, the thread is automatically created, and the asyncio is a single threaded event loop. So we get the current event loop, and then from loop we can run until complete. And what are we gonna run? Result set, and we pass 3. Yeah. So if we wanna run this as a script, you see when you wanna cover your tests, that you will need to cover also the loop. So there is a possibility, you know. Let's try that. Python compute coroutine. As you can see, we run that as a script. So there is a possibility when you want to cover your test, you also need to cover this loop. I know it's not easy, but that's why I thought it'd be better for me to just explain how you can also mock a loop in your test or in your code. Okay, let's go back. Create a new test. We call that test mock loop. Okay, the test mock loop, we take a loop as a fixture, and the loop will be an asyncio code, asyncio. The loop will be a fixture that is an instance of an asyncio abstract event loop. Okay, with the patch. So now we are mocking a loop. So a loop is an object, which is an instance of abstract event loop. So we're gonna mock an object. What are we gonna mock? We're going to mock asyncio abstract event loop, and we're gonna mock run until complete, which will return a value equal to completed. Let's pattern-ize this code as, you know, mock loop. Okay. So what's happening here? We're mocking a class event loop. We specify the function, the method that we be using. So we'll be using run until completed, and we expect the return value to be completed, and we mock that as a mock loop. So now let's instantiate our abstract event loop. We can just call LP, which stands for loop, asyncio abstract event loop, and then we run until completed. Run until completed. What are we gonna run? We're gonna run compute loop, and we need to import compute loop from compute coroutine import compute loop. So we call compute loop, we pass the int argument. Now we need to assert mock loop asserts that it has been called once. Okay. One thing you notice here, if I run this test, it will throw a fixture error because the loop should be a fixture. Let's see what's gonna happen if we test that. As you can see, we got the error, loop is not found. We can just import the loop from this test, or we can create the loop. Let's just copy this. Now paste it. Okay, our test is passed. As you can see, you know, the pytest asyncio is still complaining the fact that we've used a different technique here to we've used the unit test technique here, so it's still complaining that compute loop is not weighted somewhere here. To do that, we can make this a async, and shut down pytest asyncio, right? And then we also need to assert that this loop, we also need to use the loop. We can call loop run until completed computes loop 0 equal completed. Yes. Okay. We assert that when we run this loop, we are mocking the loop, still the same loop. we run that with computes, it's gonna be only one compute. Let's try. You now run the event loop while another event is running. Okay, so in fact, we don't really need to use this loop because we are not using that, so therefore we should or should not, that feature. Let me also delete that feature we import. Let's try it again. We should not do that. We can just await this one. Assert awaited equal complete. Let's see what's gonna happen. Okay, that's all we need. Make it simple. We this one, it was kind of like it was definitely freestyle coding. I didn't anticipate or prepare for this one. Yeah, so that's the way we can mock a loop by creating an abstract event loop, and instead that create an event loop render. So it's cool. That's all we need about testing an async IO. You can test the coroutine, you can test a task, you can also mock a coroutine, mock a loop using pytest and pytest-asyncio. To conclude this video quickly, let's introduce the object ThreadPoolExecutor. So what is the ThreadPoolExecutor? I might go back to compute coroutine. ThreadPoolExecutor is a class from concurrent module future. A ThreadPoolExecutor creates a pool where you can execute more than one thread using an event loop. Remember, when we're testing our loop in everything we just tested, we're creating a single threaded event loop where from one event you can await a different object and get the results. The inputs are coming in and coming out. But with the ThreadPoolExecutor, you can create a thread, a pool of thread where you can do a multi-threading or computing. But remember, still when we're using a thread, we are now using a CPU bounded task. We're still working on the single process multi-threading. I know it sounds crazy. Single process multi-threading. If you want to create a multi-process, you need to create the process pool executor. But we're gonna introduce the ThreadPoolExecutor. Very simple. We use concurrents, and the concurrents will allow us to create a process, and within that process we can create a thread pool. Okay, let's create another task here. Let's create another coroutine. We name the launch, or we name the results sets with the thread pool. Number of tasks. Let's make sure it's gonna be an integer. Okay. Now we need to call our context manager, or the thread pool can be run as a context manager. So with the ThreadPoolExecutor as a thread pool, or we can just use pool, but I don't like using just as pool because we don't know if it's a process pool or a thread pool. So we're using a thread pool. And don't get intimidated. I know a lot of people, okay, including me at the beginning when I was trying to grasp those concepts, the difference between creating multi-threading and multi-processing, testing them. It was kind of challenging, but hey, concepts are intimidating, but if you pay attention and try to understand different components or property of each concept, you will grasp the definition of any thread pool. Okay, now we need the results. We are going to await a loop. Yes, we need a loop, an event loop. We're gonna create our event loop as a abstract event loop. Okay, yeah. So this coroutine, we take in parameter the number of task, which is an integer, and also an event loop, so we can await from the future. And I know why we have to call this a future here. The concept future in concurrency, in Python concurrency, will refer to an awardable object that will be returned, in the future, which means that an awardable that can be executed in another thread, right? Okay, we have our event loop. We're gonna await from our event loop run in executor. Now we have a new function run in the executor. And what is this function run executor? When you run your scripts by default, you have a default thread from the process. So when we say run in executor, we are telling an event loop to run in a specified thread. So, and the thread that we need to use is the threading tool. And what is the code we need to run? We need to run our result set, which is an variable. So result set, we don't have to call literally result, they just pass it as a function. And the following arguments should be the parameter that the result sets will take. And number of tasks, not stacks. Okay, number of tasks. Yeah, that's all. And then when we're done, we just print the result. And this code should not be intimidating. We are just from a process, we create a thread pool, a pool where we can run more than one thread. Remember, an event loop is a single threaded. We could do something like a result to equal a wait event loop, and then instead of passing the number of something like this, run in executor the same thread pool result set. Instead of passing our number of tasks, we can just say 4. So you can see we have a thread of pool with more multi-threading events loop. Crazy, right? And this code, we can run a lot of tasks, a lot of CPU bound tasks or tasks that are prone memory utilization. We can do a lot of shit here. Okay, that's all. If we want to run that, we can just on a comment, instead of running result sets here, we are going to run results with thread pool, and we're gonna pass 4 like a number of tasks, and then we're gonna pass loop. Okay, let's test compute coroutine. Result set was never awaited. What's happening? Result set should be there we go. So I think we should await the result set. Normally when you're writing code with thread pool, the function in the loop should not be a coroutine, should be a blocking function, should not be an async. But since we use the async under or a loop, we should await that. So await that and then get us the results. Okay, that's all we have. So that concludes our video on testing the async code. I'll see you in the next one. See if we can continue how we can test concurrent and multiprocessing in Python. It looks like it's difficult, but it's not that difficult. It just needs some attention and understanding concepts, in the basic testing. Yeah. Okay. Thank you for watching. I'll see you in the next one.